Hello everyone. Um, we have come to the last part of this lecture series, and here discuss and we will discuss the design and calculations involved in building a hybrid solar power system. Okay, so let's begin. Solar power system, basic design and calculations. Part 505, hybrid system design and calculations. The hybrid system is almost the same as the off-grid system that we have discussed in the previous lecture. The only difference is that the solar charge controller and the inverter now is combined as one equipment. This one. There is also an added equipment, which is the ATS, or the automatic transfer switch. This one. This one switches between your normal power source, in this case your solar power setup right here, and your reserve power source or your backup source, which is your power grid or your utility. There are 4 steps involved in designing a hybrid system. Step 1 is the load analysis. Step 2 is the sizing of the solar array. Step 3 is the sizing of the inverter. And step 4 is the sizing of our battery bank. Step number 1, load analysis. The goal here is to determine what your daily power consumption is. So this step is quite simple. Just take your electric bill, check your monthly consumption, and divide it by 30 days, and that's it. So in this example, for example, we are consuming around 170 kilowatt hours per month. You divide that by 30 days, and your daily power consumption is 5.67 kilowatt hours per day. Step number 2 is sizing our solar PV panels. Now that we have calculated how much power we consume daily, we also need to determine how much sun is your location getting, or what we call the sun peak hours. So the sun peak hours is the duration at which the intensity of sunlight is 1000 watts per square meters, and the average sun peak hours is usually around 4 to 5 hours, and that value varies as you move away from the equator. There are locations where they have longer days and some will have longer nights. So this bit of information, I will let you Google yourself, find out what will be the sun peak hours for your location. To compute for the required capacity of our solar panels, we should divide the daily consumption by the sun peak hours and multiply that by 1.3. So that's 5.67 kilowatt hours divided by 5 hours multiplied by 1.3. We will require a minimum solar PV power of 1.475 kilowatts. Now suppose we have a you have your solar panel right here with a power rating of 380 watts. To compute how many of these are required, we just need to divide the PV power with the rating of our solar panel right here, which is 380 watts. So that's 1475 watts divided by 380 watts. We get 3.88, or we round this up. So we need four pieces of this 380 watt solar panel. Step number 3, that will be sizing the inverter. To size our hybrid inverter, we need to take the actual power output of our solar PV array. The solar panel that we'll be using has a power rating of 380 watts, and we then multiply this by the quantity which we have computed previously, which is 4. The result will be 1520 watts. Now this is the output of our solar PV array, and then this will also be the minimum power rating of our inverter. But since we don't have an inverter rated at exactly at this rating, 1520 watts, we will choose the next higher value available. So in this case, we'll choose a hybrid inverter rated at 3000 watts or 3 kilowatts. Next, we'll check if the other inverter parameters such as the voltage input and the current input are enough. No, okay, yeah, are enough with respect to our solar panel. Okay, now suppose we will connect our solar panels in series. Let's check its output voltage. And now for a series connection, the voltages are additive. So the total voltage output will be 48.8 volts times 4, because we have four solar panels in series, connected in series. The total voltage is 195.2 volt DC. This value is less than the maximum voltage input of our inverter right here, which is 500 volt DC. So this inverter is okay. Now let's see if the maximum input current is also enough. For a series connection, the current is the same. That means for solar panels connected in series, with each having a short circuit current of 9.94 amps, the current output of our solar array will still be 9.94 amperes. This is still lower than the maximum input current that our inverter is rated to, which is 18 amperes. So this inverter is still very much sufficient. Now to size, step number 4, to size the battery bank. Sizing the battery bank involves load analysis on the appliances you want to run on batteries. So in here you list down all the electrical equipment in your house, and for example, we suppose we have LED lights, LED TV, electric fan, a fridge, laptop, washing machine. Next, we list down the unit power for each of our appliances. Next step is to list down the quantity for each our appliance. For example, we have 4 LED lights, 1 TV, 2 fans, a fridge, a laptop, and a washing machine. Next, we multiply this unit power by the quantity. to get the total power for each type of equipment. So for example, for the LED lights, 9 watts each light times 4 quantities, we have 36 watts for the LED lights, and so on and so forth. Next, we'll list down the duration at which we operate this equipment. So for example, for LED lights, we will use it for 7 hours, TV 5 hours, fans for 8 hours each, for the fridge 10 hours, laptop 4, and a washing machine 2 hours for the laundry. Now we shall multiply this total power by the duration, and we'll have the power consumption for each equipment type. We sum this all up and we have the total power consumption that we require to total power consumption of the equipment that will run on batteries. And after this, we shall now size the battery bank. The battery bank capacity depends on 4 factors, namely the daily power consumption, which we have calculated in the previous slide, the DOD, or the depth of discharge of the battery, the efficiency of the battery, and the system voltage. The system voltage is primarily depends on the user. As a guide, a 12-volt system is suitable for small installations, particularly 1200 watts and smaller. A 24-volt system is suitable for medium-sized installations between 1200 watts to 2400 watts. And the 48-volt system is mainly used for large installations, such as 2400 watts and above. So to compute the battery bank capacity that is required, we divide the daily consumption, which is 5 kilowatts, by the product of the DOD, 0.5, times efficiency, 0.85, and times 48 volts for our system voltage. So our battery bank capacity would be 245.69 ampere hours. This is our computed required battery bank capacity. Now suppose we have a battery bank right here with a 12-volt output, 250 ampere hour capacity, a DOD of 50% and efficiency of 85%. We'll need to compute for the required battery capacity. We'll have now to compute for the series and strings. The series and string configuration of our battery bank. So to compute for the number of strings, we shall divide the required battery capacity, 245.69, and divide this by the battery capacity rating of our battery itself. So that's 245.69 ampere hours. divided by 250 ampere hours. So number of strings will be 1. To compute for the number of series, we need to divide the system voltage by the voltage rating of our battery. So that's 48 volts divided by 12 volts, and we have 4. So that means we need 4 of these battery right here connected in series. So that's it. 1 string and 4 pieces batteries connected in series. Okay, so now that we have all the data that we need, let us build our hybrid system. The hybrid system is composed of 4 major parts: the solar power array, the hybrid inverter, the battery bank, and the ATS, or the automatic transfer switch. The solar panels convert solar energy into electrical energy, and this electrical energy will then be used to charge the battery bank through the hybrid inverter. The hybrid inverter has a built-in charge controller that prevents the battery bank from overcharging. This hybrid inverter also converts DC voltage from the solar panels or the battery bank into AC voltage that can be used by the regular household appliances here. The hybrid setup is connected to the power grid so that during the day it can function like an on-grid system while also charging the batteries. And during the night or during blackouts, the batteries will be utilized to power up the loads, just like the off-grid system. So, but when the stored energy in the batteries is depleted, the ATS automatically switches to the reserve or backup power source, and that will be the grid. Okay, in step 1 we have computed the daily power consumption by dividing the monthly electric consumption stated in the electricity bill by 30 days. In this example, the daily consumption is 5.67 kilowatt hours per day. In step 4 we have also computed the required battery bank load, which is 5 kilowatts. That is right here. In step 2 we have determined that for a daily consumption of 5.67 kilowatt hours we need 4 pieces of this 380 watts solar panel rated at 380 watts. In step number 3 we calculated that the inverter should have a rating equal to or higher than the power output of our solar array, which is 1.52 watts. And this example we chose an inverter with a power rating of 3 kilowatts, which is higher than this. In step number 4 we have chosen which appliances are to be operational during the night or during blackouts. We have computed that the total load consumption would be around 5 kilowatts right here. So in order for our battery bank to supply power to this amount of load, we need around 4 pieces of 12 volt battery rated at 250 ampere hour each. And the next step is to compute for the circuit breakers. Yeah. Okay, so DC circuit breaker number 1, this one. This is at the output of the solar PV panel. So to compute this, we need to multiply the short circuit current of our solar panel, which is 9.94 amps, and multiply that by the number of strings. In this case, we only have one string of solar panels, and multiply that by 1.25 as the buffer. So the current flowing through here is 12.42 amperes. In this example, we'll choose 14 ampere trip 2-pole DC circuit breaker. DC circuit breaker number 2 is at the output of the is at the input of our inverter, or at the output of our battery bank. So to compute this, to compute the rating of our DC circuit breaker number 2, we need to divide the maximum power of our inverter, that's 3000 watts, divided by the system voltage of our battery, which is 48 volts. So that's 3000 watts divided by 48 volts. We have 62.5 amperes. That's the amount of current flowing through here. So in this example, we will choose a DC circuit breaker with a rating of 70 amperes. So that's 70 ampere trip 2-pole DC circuit breaker. For the AC circuit breaker, at the output of the inverter, just before going to the load, we can compute this rating by dividing the maximum power of the of the hybrid inverter, which is 3000 watts, by our grid voltage, which is 220 volts. Again, this is an error. This should be AC, current AC. So that's 13.64 amperes. That's the amount of current flowing through here. So in this example, we will choose a an AC circuit breaker with a rating of 14 amperes. So that's 14 ampere trip 2-pole AC circuit breaker. So the other accessories are the DC and AC isolator. These two functions as a switch that you can manually operate to turn on and off or isolate certain parts of the system. So in this case, the DC isolator can isolate the solar panels from the rest of the system, and the AC isolator can isolate the solar power system from the grid, which is the power grid, which is your utility. The AC SPD and DC SPD are your surge protection devices. So they protect your system from current surges by directing the surge current flow to the ground instead of going to your equipment, which can harm your appliances. So I think that's all. Yeah, so that wraps up our 5-part lecture series, and I hope you have gained some knowledge on solar power systems. I encourage you to read more and research more if you want to build your own solar power system. And yeah, I hope you had a great time learning. Have a good day ahead, and please don't forget to like and subscribe. And yeah, see you if I make any lecture series, that would be something similar, or um, maybe with regards to telecommunication systems. I will let you know. So I'll keep you posted. So have a good day ahead, and goodbye.